Hello everyone, this is Hema Boddupalli, a final year BTech student at VMTW Gatkesar. First of all, thanks to Sitafal Technologies for giving me this opportunity. I personally explored a lot while completing this task. In today's video, I will talk about an exciting project named WebGPT that combines NLP, ML and web scraping to build an intelligent web-based Q&A system. This system answers user queries by analyzing and retrieving relevant information from scraped context. I will walk you through the problem statement, the architecture, the code behind it and the outcomes we achieved. Without further ado, let's dive in. Problem statement. Imagine you need to find an answer to a specific question. Manually searching through these pages is time consuming and inefficient. Our goal is to build an intelligent system that can scrape content from websites, understand the context and provide relevant answers to user queries in real time. Architecture. Let's now take a look at the architecture of the system. This is a high-level overview of how the system works. User enters a query through the UI. The first step is scraping context from web pages. We extract text from paragraphs and other useful context, which will serve as the knowledge base for answering users' queries. Once we have the context, we split it into smaller manageable chunks. This allows us to process efficiently and makes it easier to retrieve relevant pieces of context later. We then use a pre-trained model to generate vector embeddings for each chunk of text. These embeddings represent the semantic meaning of the content, making it easier to compare and retrieve the most relevant information based on the user's query. To quickly search through the embeddings, we use FAISS, a fast similarity search library. FAISS indexes the embeddings and allows us to store and retrieve the most relevant chunks when a query is made. When a user submits a query, we convert the query into an embeddings, then perform a similarity search in the FAISS index to find the most relevant context. Finally, we generate a response by extracting the relevant chunks and presenting them to the user. In some cases, we refine the responses to ensure it is accurate. Let's quickly check out how the system works before going through the code. In this website, currently the ingested content is about nutrition in plants and animals, which is taken from biology blogs in Byju's. If we enter a question like what is nutrition, it is able to retrieve the context based on the knowledge articles provided as base and summarize the answer and display the context as well as refined answer here. Let me ask one more question for demonstration. What is chlorophyll? Here's the context and the answer. Now let's talk about the code behind this system. We use several tools and libraries to bring this project to life. I have implemented this project using Google Colab's notebook in Python. Initially, all the required libraries for the project are installed. Then each step described in the architecture has a function defined in the code as follows. Web scraping, request and beautiful soap. These libraries are used to scrape the content from the web pages. We use request to fetch the HTML content and beautiful soap to phrase and extract the text. Text chunking. It is done manually in the code by splitting the scraped text into smaller chunks. Embedding generation. The pre-trained All-Mini LM V6 V2 model from the sentence transformer library is used to generate embeddings for each chunk of text. This model helps us convert text into vector representation, making it easier to compare and retrieve relevant information. Indexing and retrieval. We use FAISS. It allows us to index the embeddings and quickly find the most relevant chunks based on the user's query. Summarization. For generating concise responses, the response received from FAISS is transformed using the Hugging Face Transformer library with models like BERT for summarization. This helps us condense large amount of information into easy to read answers. Front end. The user interface is built using Streamlit and ngrok, a powerful framework for building interactive web applications. It allows users to input their queries and view the responses in a clean and user-friendly format. Additionally, some beautifications of answer is done before the displaying to user. Outcomes. The outcomes of the projects are effective information retrieval, user-friendly interface, real-world application, context-aware response. Thank you.